Good morning. So in this video, we're going to discuss combustion. So combustion is a special or important type of reaction in chemical engineering. So generally, most of the energy that we need in chemical industry, we obtain this from combustion of uh, of fuels. So first, we're going to discuss some basic concepts in industrial combustion, and then we're going to solve some problems from Himmelblau. Okay. So the first concept that we're going to discuss is uh, flue or stock gas. So basically, flue or stock gas is the term used to refer to the product of combustion. So for example, if you're going to burn LPG, LPG gas, liquefied petroleum gas, basically it's a reaction between C3 and C4 hydrocarbons and oxygen. And then your product will contain oxygen, nitrogen, carbon dioxide, and water. Or if you have incomplete combustion, you will have additional carbon monoxide. So these gases that result from the burning of fuel is known as flue gas or stock gas. Generally, in terms of analysis, the flue gas or stock gas analysis contains the percentage of water. And then when the percentage of water is stated in the analysis, this analysis is known as the wet basis of analysis. So as stated in Himmelblau, flue or stock gas are all the gases resulting from a combustion process, including the water vapor, sometimes known as wet basis. So yung analysis niya that contains the water, the percentage of water is known as the wet basis. Okay. So the opposite or the other type of analysis is known as the ORSAT analysis. So basically, pag ORSAT analysis naman, it doesn't contain or it doesn't include the moisture content or the percent water. So the ORSAT analysis right here, the ORSAT analysis right here is also known as the dry basis or DB. So in ORSAT analysis, all the gases resulting from a combustion process, not including the water vapor, okay? ORSAT analysis refers to a type of gas analysis apparatus in which the volume of the respective gases are measured over and in equilibrium with water. Hence, its component is saturated with water vapor. The net result of the analysis is to eliminate water as a component that is measured. So basta ganun, basta ORSAT analysis, expect na walang percentage water. Excluded yung water. Okay? So we're going to you're going to encounter these terms, no? When we are going to solve when we're solving combustion problems. Okay. So the next concept is complete combustion and partial combustion. So when complete combustion refer to the conversion of carbon to carbon dioxide, of sulfur to sulfur dioxide, and of hydrogen gas to water. So basically, pag sinabing complete combustion, wala kayong carbon monoxide. Yun lang naman yun. Ano? And then, in the other one, or in sa kabaliktaran, you have partial combustion. So pag partial combustion naman, the product of the combustion contains carbon monoxide. So partial combustion, the combustion of the fuel producing at least some carbon monoxide. You know, because carbon monoxide itself can react with oxygen. So, di ba, CO plus O2 will give you CO2. The production of carbon monoxide in a combustion process does not produce as much energy. Kasi ano yan eh, partial combustion. As it would if only CO2 or carbon dioxide were produced. Okay? So, at this point, you must be able to differentiate between complete combustion and partial combustion. Basically, basta may carbon monoxide, CO, partial combustion yun. Pero pag absent yung carbon monoxide, complete combustion yun. So, ginagamit kasi ito sa sa problem solving, no? So, kung minsan may mga problems na given na complete yung combustion, so pag ganoon, ang problem, i-assume nyo na walang carbon monoxide sa product. Tapos, at saka yung complete combustion, usually ginagamit din yan sa susunod nating concept. Ano? Dun sa excess oxygen at saka yung theoretical oxygen. Pag theoretical oxygen, ina-assume nun na yung combustion is complete. Okay? Okay, so we have this next concept, theoretical air versus excess air. Okay? So pag sinabing theoretical air, it assumes complete combustion, no? Kumbaga, this is the air or oxygen required for complete combustion. Ibig sabihin, all of the carbon will be converted to carbon dioxide and all of the hydrogen is converted to water. Kung may sulfur, all of the sulfur is converted to sulfur dioxide. So this is the minimum amount of air or oxygen required to be brought into the process for complete combustion. Sometimes this quantity is also called the required air or required oxygen. So another concept is excess air or excess oxygen. So this is in line with the definition of excess reactant. Ano? So yung excess air, generally this is the actual amount of air or actual amount of oxygen. And then if you're interested on percent excess air, this is simply excess minus theoretical, no? Kung percentage divided by theoretical. Ano lang naman yun, ano? Common sense lang naman yung percent excess air. So, kahit isipin nyo lang, huwag nyo nang i-memorize yung formula, ano? So, this is, excess air is the amount of air in excess that of required for complete combustion. Ano lang. Makikita nyo yan mamaya saan? Sa problem na isosolve na. So, excess air. So, let's try to solve a problem sa excess air. This is example 10.7. Okay. Fuels other than gasoline are being eyed for motor vehicles because they generate lower levels of pollutant than does gasoline. So, compressed propane is one such proposed fuel. Suppose that in a test, 20 kilogram of C3H8, that is your propane, is burned with 400 kilogram of air to produce 44 kilogram of carbon dioxide, 12 kilogram of carbon monoxide. What was the percent excess air? So basically, generally, sa combustion. Generally, sa combustion, ang excess, most of the time, is air. So you could also confirm that by several methods. Pwede kayong gumamit ng napag-aralan nyo sa GenChem. Pwede nyo i-calculate yung Emax, no? Or pwede nyo rin i-assume na yung air ang excess. Yung air ang excess reactant. Tapos yung fuel, yun yung limiting reactant. And then in the end, after calculation, you can double check the result. Ano? And then ganun. So, since ang tinatanong dito is percent excess air, and as I previously mentioned, percent excess air, just by thinking, hindi nyo naman kailangan i-memorize, that is basically equal to actual air minus theoretical air divided by theoretical air. So, times 100%, of course. So, what we're going to do with this problem is we're going to calculate the amount of theoretical air that 20 kilogram of propane, C3H8, needs. No? So, first, you're going to write the balance equation of combustion of propane. No? Tapos, yung 20 kilogram of propane na given sa problem, using that, no, and then conversion, stoichiometric ratio from the reaction, molar mass ng air, molar mass ng propane, you should be able to calculate the theoretical amount of air in terms of kilogram of air. No? Tapos yun, pag meron na kayo noon, yung actual, so yung theoretical, so 400 kilogram, that's the actual, minus minus the theoretical, divided by theoretical, times 100%, yun na yung percent excess air. Ganun lang, Let's try to solve this problem. Okay. So first I'm going to solve the balance equation for the combustion of propane, So that's C3H8. And then you're going to react this with oxygen. Tapos we're going to get carbon. So the product of combustion is always carbon dioxide and water. And then I hope you still remember how to balance combustion reaction. So, yung stoichiometric coefficient ng carbon dioxide is usually the number of carbon. Yung 3 na yun. So, place 3 right here. Tapos yung sa water naman, i-divide nyo yung number of moles ng hydrogen. So, halimbawa, ito is 8, This is 8. So, 8 divided by 2, yun yung stoichiometric coefficient ng water. So, 4. Okay? And then balance oxygen. So, you will need 3 moles of oxygen plus 4 divided by 2. So, that's 3 plus 2. You need 5 moles of oxygen in the reactant. Okay, you can double check that. You have 10 oxygen right here. Tapos dito 6 plus 4, that's 10. So we have a balanced combustion reaction. Of course, you can confirm carbon, 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens. That's how we have the balanced combustion reaction. Next, we're going to calculate the theoretical oxygen. Or theoretical air. Let's calculate theoretical air. Kasi yung given dito is 400 kilogram of air. So what we're going to calculate is kilogram. What we need to calculate is kilogram of theoretical air. So probably we can start with 20 kilogram of propane, C3H8. So the next step is to convert this to moles of propane or kilogram moles of propane. So the molar mass of propane is, of course, I hope you know how to calculate molar masses. So in my calculation, it's 44. The molar mass of propane. Diba? It's simply 3 times 12 plus 8. So this is 36. 36 plus 8, that's 44. So just multiply this by, or divide this by 44. You have 44 kilogram C3H8. And that's for every kilogram mole of C3H8. Okay? So next you're going to use the stoichiometric ratio. For every 1 mole of C3H8 or propane, you need 5 moles of oxygen. 5 kilogram moles of oxygen. So we're going to multiply this with 5 kilogram mole of O2. Okay? Tapos, syempre, this is per kilogram mole of C3H8. Okay? So this one is coming from the balance reaction. Ano? Tapos we're going to convert the kilogram mole of O2 to air. So for every 21 kilogram mole of O2, there will be 100 kilogram mole of air. Okay? And then we're going to use the 29. The molar mass of air is 29 kilogram per kilogram mole. Yun yung kay Himmelblau. Ano? 29. Ito yung molar mass ng air. So this is kilogram per kilogram mole. So just use the calculator to find the theoretical amount of air in terms of kilograms. So 20 divided by 44 times 5 times 100, okay, divided by 21 times 29. So I got something like 313.85. Okay? Got 313.85 kilograms. Okay. So with that, let's calculate the percent excess air. So percent excess air is equal to number of moles of air. Basically, this is equal to actual air minus theoretical air divided by theoretical air. Ano? You don't really need to memorize that. You just need to think. Just need to think. So actual air minus theoretical air divided by theoretical air, okay, times 100%. So this would be 400 kilogram. Ito yung actual air na given, di ba? Minus 313.85 or 314 divided by theoretical, 313.85. So times 100%. So more or less, you're going to get something like 27.45%. Okay? So this is equal to okay? So I hope you find this problem quite easy. Next, let's consider another one. So as you can see, this problem illustrates the concept of excess air, Tapos also yung product ng combustion, the carbon dioxide, the water, and the excess oxygen and nitrogen kasi air ginamit natin, and the carbon monoxide, all of these is referred to as flue gas. Okay. So let's try to solve another problem. You know, this is example 10.8. A fuel cell to generate electricity from methane. A fuel cell in every car is the headline of an article in Chemical and Engineering News, March 5, 2001, page 19. In essence, a fuel cell is an open system into which fuel and air are fed and out of which comes electricity and waste products. So figure E10.8, the one below, is a sketch of a fuel cell in which the continuous flow of methane is used. So as you can see from the drawing, no? Halimbawa, the feed is 16 kilogram of methane, that is 100% methane. And then you're going to use 300 kilogram of air. Yung air, ang composition is 21% oxygen, 79% nitrogen. And then, pag hindi given yung composition ng air, palaging ganito, ano? Palaging ganito yung composition ng air. 21% oxygen, mole percent, 79 mole percent nitrogen. Tapos basically, you are asked kung ilan yung moles ng carbon dioxide, ilan yung moles ng, or kilogram mole, ano? Kilogram mole. Ilan yung kilogram mole ng nitrogen, ilan yung kilogram mole ng O2, ilan yung kilogram mole ng water sa product. Now, assuming complete combustion, wala tayong carbon monoxide. Tapos ilan yung total number ng kilogram mole. Okay? So solve natin yung problem ng ganun. Yun yung tanong. So basically, ano lang naman to, extent of reaction lang. No? Extent of reaction. Between, generally, katulad ng sinasabi ko sa inyo kanina, between the fuel and air, usually, fuel yung limiting reactant. So, ang molar mass ng methane is 16. So, this 16 kilogram ng feed is equivalent to 1 kilogram mole. Okay? So, actually, pag complete combustion, as you can see, walang ng methane sa product, no? So, lahat ito, probably you can write the balance equation and you can predict from the balance equation how much carbon dioxide will be present, how much water will be present, no? Ang nitrogen is not reacting, you know? It's not reacting. So, whatever nitrogen is present in air, incoming air, will be the nitrogen present in the product. So, madali lang i-calculate yung nitrogen. Oxygen, yung excess oxygen would be the amount of oxygen in the product. So, halimbawa, ang theoretical ay, we will see on the balance equation, ano? Kung halimbawa, dalawang kilogram mole ng oxygen yung pumasok, isang kilogram mole yung theoretical, so matitira is 1 kilogram mole of oxygen. Ganun lang yun, ano? You can use the extent of the reaction or you can simply use the ano. Depende sa given. In this particular case, eksakto isang kilogram mole yung pumapasok. So you can easily calculate the number of moles in the product. So let's try to solve this problem. Okay. So first, let's try to solve the balanced chemical reaction. So we have methane. And then we're going to react this with oxygen. Tapos we're going to have carbon dioxide and water. Ito yung product ng combustion. So kamukha ng tinuro ko sa inyo kanina. Yung carbon dioxide dito, 1. Ang kanyang stoichiometric coefficient kasi isa lang naman yung carbon natin. So 1, ito na lang ilalagay. Tapos yung water, 4 divided by 2. So 2 yung 2 yung stoichiometric coefficient ng water. Tapos, balanced oxygen, so you have 1 plus 1. no? 2 divided by 1, so 1 plus 1. So you will need 2, so 2. No? For every 1 kilogram mole of methane, you will need 2 kilogram mole of oxygen. Ano? Then as you can see, kung ilan yung kilogram mole ng methane, yun na rin yung number ng kilogram mole ng carbon dioxide. So from this balance reaction, you can conclude that CO2 is equal to, diba? You can conclude that is equal to 1 kilogram mole of CO2. So yun, so nasolve na natin itong unang requirement. Ano? Next, let's try to find nitrogen. Kilogram mole of nitrogen. So sabi ko nga sa inyo, hindi naman to nagre-react. So all you need to do is to quantify the amount of nitrogen from the given weight of air. So ang given weight of air is 300 kilogram. You have 300 kilogram air. So probably, siyempre kasi kilogram mole yung kailangan natin. You can convert this to molar mass. So simply divide this by 29. That's the molar mass of air. Kilogram air per kilogram mole of air. Tapos, as you can see, this will give you the kilogram mole of air. Tapos, use the ratio. Ano, for every 100 kilogram mole of air, there are 79. Ito, di ba? 79. Pero you need to memorize that. 79 kilogram mole of nitrogen. So, cancellation. Okay? Cancellation will show you that with this equation, you can solve the kilogram mole of nitrogen. So, ilan ng nitrogen? A simple pressing in the calculator will give you 8.17. Ano? 8.17 kilogram mole of nitrogen. Okay, I will clear this space right here. So, lagay ko na lang dito yung mga sagot. Carbon dioxide, we have 1 kilogram mole. See, mabubura din nga pala yun. Tandaan lang natin. 1 kilogram mole at saka 8.17 kilogram mole. I'm just going to clear this para may masulatan tayo. So, carbon dioxide is 1 kilogram mole, and then nitrogen is 8.17 kilogram mole. Let me check. Yeah, that's correct. No? What about oxygen? So basically, oxygen, ganun din. If you still recall the balance reaction, CH4 plus 2O2, okay? This will give you CO2 plus 2H2O. Okay? So the theoretical amount of oxygen is 2 kilogram mole. Kasi, di ba, ang input nating methane 1 kilogram mole. So, ang theoretical na oxygen natin ay 2 kilogram mole. So, the question is, how many kilogram mole does 300 kilogram of air contains? No? So, tingnan natin. Basically, let's find out ilan yung excess oxygen. Ano? So, let's start with 300 kilogram of air. Ano lang yan? Tinakita nyo conversion lang. 300 kilogram of air. Ganun ulit. Divide natin ng 29, which is kilogram per kilogram mole of air. Tapos, Okay. Tapos ano, let's calculate the amount of oxygen. So how do we do that? We're just going to use the 21 per 100, no? 21 kilogram mole of oxygen per 100 kilogram mole of air. So by cancellation, you can see that this value will lead you to kilogram mole of oxygen in the feed. Ano? Yung actual. So just subtract the answers. Halimbawa, this will give you 2.17, no? 2.17 of oxygen. Yun yung actual. This is the theoretical, no? So the difference between the theoretical and actual is 0.17 kilogram mole. So the amount of oxygen in the product is 0.17. Okay, so we have 0.17 kilogram mole. Okay, so isa na lang. Ito na lang, water na lang. So to solve water, actually you can use this balance reaction. Ano? Kasi special case eh. You have 1 kilogram mole of methane, so expect that you're going to have how many kilogram mole of water? 2, no? Kasi for every 1 mole of methane, you'll be producing 2 kilogram mole of water. So water is 2 kilogram mole. Okay? So to get the total kilogram mole of product, you just add this, get the sum, no, of the kilogram mole of each component. So 1 plus 8.17 plus 0.17 plus 2. So P is 11.34. Okay? So I hope you, of course you can also use ano, kasi basically this is just another reaction. You can also use the extent of the reaction concept to solve ano, to solve combustion problem. So as you can see, it's quite easy. We'll be discussing more complicated problems in the future slide. Okay. So I guess this topic, this combustion topic will be will include this in the final exam. Ano? Para yung midterm nyo will only cover extent of the reaction and chapter 9. So in chapter 9, kung natatandaan nyo pa yung selectivity, conversion, okay? Those concepts in chapter 9. Probably yung elemental balance sa midterm din. Ano? I'll be posting the midterm exam soon. For now, I'm going to find an exercise for this topic and then try to answer. So see you in the next video. Bye.